So one of the cool things about vectors, one of the many cool things, is that y'all see them every day and you don't even realize it. Any of you that play video games, if you are looking at the graphics on a video game, everything in the background is vectors. You know, where the reflection of the light is. It's somebody in the background having to use vectors to tell that light where to focus or to tell an object where to move, and it is all vector math. Another thing is in the future when you're in physics, you'll be using vectors a lot of times for the forces that act upon one another. When you're in pre-cal, you'll be using it for airplanes, and this is a really cool thing because when you go on a trip and you're in a plane, and you know, obviously your airplane's up there, but there's things like wind and gravity and things that affect the flight of the airplane. And the plane runs on vector paths where it has to constantly adjust the speed and the direction of the flight course that it's on to make sure that it gets to the right location. So that's all programmed into the airplane and how it flies. So it's pretty cool stuff. Now, we're going to go ahead and transition to how to draw them accurately from a description and actually finding angles and magnitude, okay? So let's do this first example. Sketch a vector in the direction of 10 degrees east of north, then find the magnitude of what you just sketched. Okay, so first of all, magnitude means what? It means the length, okay? So we need to know how long this thing is, and we need to make sure that we sketch it correctly. So when you look at the angle, 10 degrees east of north, it's important to know your compass. Hopefully everybody knows this. I heard somebody once say never eat soggy waffles. I don't know, that's how they remembered it. So there's a memory trick for you. But we need to be able to sketch this, right? So where do we start? Well, it's east of north. So whatever is the of is where you start. Okay, so I'm going to start in the north. Then I'm going to go 10 degrees east of that, okay? So east is to the right, so I need to go about 10 degrees over. Now, I'm going to say about because I do not have a protractor, okay? But you guys do. Now, you can choose how long you want this thing to be. We could make it stop. Let me do this. We could make it stop right here if we want, okay, and call that 10 degrees. Or we could make it keep going and see where that hits. You know, it's really up to you. So I'm just going to draw a random. Okay, 10 degrees. I'm going to make it stop right there. All right, so cool. If this is you, or whatever you drew, you basically just want to show that that's where the 10 degrees is, and that could be the direction. And then get your ruler and measure. Okay, so I don't know how long mine is. Mine is just shy of an inch. So I'm going to put 1 inch, so for magnitude. But it could be whatever you guys chose to do, okay? And that's what we're going to do for finding magnitude when we've drawn our own. So not bad, right? Okay. So let's go on to the next one. Sketch a vector that's 55 degrees south of west. Okay, so for this one, do we start in the south or do we start in the west? Well, we always start in the of. North, south, east, west. Okay, so I'm going to start in the west, and I'm going to go south of that 55 degrees. So really and truly, guys, grab your protractor and really measure that, okay? Like as accurately as you can with a protractor. You may have to turn your picture upside down so that you can measure that correctly. I don't know, but I don't have a protractor, so I'm having to guess. But I want you to really look at that, and then you're just going to measure how long it is. So mine this time looks to be a little more than an inch, so maybe mine's like an inch. Maybe it's like 1 1/8 of an inch or something like that. But you would grab a ruler and actually measure that, okay? The next one, can you describe the magnitude and direction of the vector shown here? Okay, I really like these because this is where math is involved, not a ruler. So if it's already sketched for you, you get to use math. You get to use things like, we're going to be using the Pythagorean theorem. We're going to get to use SOHCAHTOA and things that you already know to be able to actually find this stuff out. So that's what I like about when they're already drawn for you. So the first thing I'm going to do is magnitude. Now magnitude, of course, is how long is this. Now what my brain has always done is I view this as a hypotenuse, and I just make a right triangle out of it. So I go up to my x-axis. By the way, I always draw mine with the x-axis. That's a good habit to get into before physics and pre-cal. So I could have gone over to the y, but I didn't. I just went straight up to the x. And the reason I did this is because I can count, right? This is 1, 2. This is 3 units this way, and it's 2 units down. And if I view that as the hypotenuse, then my magnitude is just the c. Like, how long is that? Well, a squared plus b squared equals c squared. So for me, it's going to be 3 squared plus 2 squared equals c squared. That would be 13, I believe. So c is the square root of 13. Now, if you want to, I don't even want a decimal, just leave it as the square root of 13. This doesn't simplify, so that's as good as it's going to get. So square root of 13. Yay! All right, cool. Now what about the direction? Well, the direction is the angle. Okay, so just by looking at this little angle, let's do the words first, right? So like, would you call that, north of east, south of west? What would you call that? Well, the way I see it is this thing started in the east, and then we drew it down south of that. So it's going to be some kind of angle south of east. And this takes practice to get good at this. If you're terrible at this, just ask friends or a teacher for one-on-one instruction until you get good at that. But it really is looking at where's the vector and where could it have started and then stopped. So that's kind of how I do that. Now let's find the actual angle. Well, if you want this actual angle, that is why we know SOHCAHTOA. You know what I'm saying? So when I look at this, this is what I'm trying to find. I know the opposite side is a 2. And I know the adjacent side is a 3. So I'm going to pick up my calculator and I'm going to type in inverse tangent of 2 over 3. Now, why inverse tangent? Well, if you remember correctly, the inverse functions are when you're looking for the angle. They will find the angle for you if you do inverse functions. And 2 over 3, because it has to be opposite over adjacent. So once you type that in, you will get your angle. So let's make sure we're in degree mode. Let's type it in, and we should all get the same thing. Okay, I just typed it in, and I got 33.7 degrees, okay? So, and then of course the south of east is behind it. So based on a random picture, I actually really like it when it's already drawn because I can look at where does it stop. I can easily find a Pythagorean theorem and then do some SOHCAHTOA, and I'm not having to measure with a protractor, right? Like, no protractor is going to get you that accurate, or a ruler is not going to get you that accurate, so it's nice when it's drawn for you. So for your practice, the first 2 is more about the angle and using a protractor, right? And then we get to do some of the actual mathematical ones down here when you go to practice. And even though I call this a challenge problem, I really think everybody should be able to try it. Especially it's like pulling the last 2 lessons together. And once you finish this, you really, really, really want to make sure you understand. I'm going back in time. This one. If you haven't done this yet, make sure you talk to your teacher, because the last part of the vector unit, if you make it there, is a treasure hunt, and you have to know how to do this before you can focus on the treasure hunt. So feel free to ask, and then y'all are on your own to see if you get there. All right, good luck, and see you soon.